of what organisms have done to make our worlds better. So first, we'll be introducing biomimicry. So we are the NCST, the National Commission on Science and Technology, and we are mandated. We are an umbrella organization which is mandated in advancing the national policy and strategy on science and technology, as well as innovation in Jamaica. We're also mandated to promote sustainable development through education and through partnerships with different entities and organizations. One of our main targets is increasing science capital, which is how much people know about science in Jamaica and in general. So with that, we want to make sure that people are aware of what science and technology are, science, technology, as well as innovation. We want to make sure that people understand why science is important, why it can benefit us in our daily lives and throughout our entire culture, as well as make people aware of scientists and their work. What exactly do scientists do, who they are, and what benefits do they provide to our own societies? And before we go on, I will be introducing myself. I am Gavin Campbell. I am the Director of Research at NCST, and I'll be presenting on biomimicry, which is also known as biomimetics. So biomimicry is essentially just copying nature. There are so many different innovations that have been derived from natural organisms that can be applied into society, and biomimicry is aimed at doing just that. So from bacteria, plants, animals, there have been several innovations that can be used to advance science and also development. Scientists who study these particular organisms, they focus on how these processes work so they can understand it down to the nitty-gritty, and get those applications into different technologies and throughout innovation. They also introduce new ways of thinking and problem solving. So once they understand how something works, they understand how they can apply that particular thing to other challenges. And technology is the application of science. So once they find out how that particular thing works, they can apply it into different manufacturing industries, different developments that can help to sustain different industries. So they translate what nature has already created into what society can benefit from. And these innovations in technology have been useful in improving different ecosystems, as well as creating new products. Some of the applications of biomimicry include aerodynamic and hydrodynamic design to make things move more easily through water or through air, architecture for buildings and such, new products, they create different products that we never even had thought of, robotics, how different animal systems can be applied to robots to make them more efficient and more coordinated in general, as well as being applied to medicine, which is helping to make sure that everyone is living a healthy and long life. So the first innovation that we'll be talking about that has been derived from studying organisms is going to be about plant burrs. So plant burrs are small fruits or seeds that have small hair-like projections on them. They attach to hair, clothing, and fur. And in doing so, this aids in their seed dispersal. So in doing that, they can attach to an organism that's moving from one place to another. And then once it reaches to another location, it can detach and grow its seeds there. And here is a picture of some plant burrs. I'm pretty sure most people would have some experience with burrs, having lived in Jamaica or even across different parts of the world. So you go through some types of bush, you will definitely be coming across burrs on your body, on your clothes, overall. So George de Mastral from Switzerland in the 1940s found an interesting feature of the burrs. He noticed that they were sticking to his dog's fur. As mentioned before, burrs are really sticky. They do stick to objects. So he noticed that they were sticking to the dog's fur, and he wondered how exactly that was possible. So in looking at the birds under the microscope, he saw that they had this microscopic structure. And with those small projections mentioned earlier, there were these hooks at the end. So these tiny hooks are what allowed those birds to actually stick to the fur and to stick to organisms as well as clothing. And there are several of them. So there are several hooks, and that ensures that they're more secure on whatever they attach to. So in developing this idea, he came up with Velcro. So Velcro is made up of a strip of hooks, this one here at the bottom, and also a strip of loops. And each of those hooks gets fused into one of those loops, and that creates a secure attachment to make sure that Velcro is pretty sturdy. So whatever you do attach them to, it becomes pretty firm and hard to rip off overall. So the hooks secure it in the loops and gives great adhesive strength. So just like the birds attaching their hooks onto fur or onto clothing, the Velcro hooks also attach to these loops to give them a secure grounding on whatever they're connecting. So the next innovation that we'll be looking at is butterflies and structural color. So everyone knows butterflies, gorgeous, love them. So blue morpho butterflies are these particularly iridescent butterflies. They have great bright blue wings that look just like this. And on their wings, like all butterflies and moths, they have these ridge scales. So this is an entire scale, and you can see different ridges on that scale itself. It is shiny and metallic in color, but this color is not from pigment. There is no particular pigment molecule that is giving it this blue, this bright blue color. It is derived not from pigment, but from structural color, which is less intensive. So instead of making or using energy to make new pigments, they just have this particular structure within their scales, and having light around, they can reflect blue in any direction at all to make them always look so bright and beautiful. In the 17th century, Robert Hooke noticed that these butterflies were, in the 17th century, Robert Hooke noticed that peacocks shared the same feature. They were iridescent, which means that they look different. They have a different color from different angles. If you look from the left or the right, they look a little bit different. And he noticed that that was one particular structure that was not mimicked in other pigments or in pigments overall. So when white light is shone on these particular structures, they do display a color because of the light being reflected from the surfaces. So this is as a result of diffraction, which is the spreading out of waves, interference of different wavelengths of light, as well as the scattering of light. So depending on the different structure of these scales, so scales here, a smaller structure, this is one particular scale, and within these scales, there are these ridges as well. So second set of ridges, and in reflecting light, it can reflect only light of a particular wavelength, and that will give you that color without there being a need for any type of pigment. So just like the butterfly reflecting light to give that blue metallic color, we can use the understanding that we've gotten from these organisms to reflect color as well too. And this can be used in paint as well as electronic displays. So paint does not need to have any particular pigment molecules for it to be able to reflect light and give that particular color that you're looking for. So this from Lifescape is one example. This is made completely from structural color. There is no pigment attached to it. Everything is just the reflection of light moving from white light, from sunlight, and then reflecting, hitting on the surface and reflecting only blue light. So you'd only see blue. So the small particles in paint allow that reflection of light. So there's no need for pigment. It's just as long as the particles are there, they can be applied to paint as well as electronic displays. So it's a type of non-pigmented paint that is still colorful and actually more environmentally friendly because it doesn't have any volatile organic compounds that are released into the air that might be a bit toxic or nauseating for some particular people. And one added benefit is that it does not fade over time. So you will have this particular structural color. As long as there is light, it will be able to reflect that light to make it blue or whatever color you do desire, but it does not fade over time. So you can keep it consistent and keep it going for a pretty long time. Oh, also, when it comes to the butterflies, Even when they're dead, they still can reflect that color. So no matter how long it has been, as long as their scales are intact, they can still maintain that, which is another added benefit overall. So structural color has also been used in Qualcomm's Mirasol display, which is an electronic display. It uses an array of moving mirrors to reflect different wavelengths of light to give you different colors depending on whatever screen you're looking at. So if you're looking at a blue image, it will move the mirrors to reflect blue light. If you're looking at a red image, it'll reflect the image. It'll move the mirrors, sorry, to reflect a red image. So these different wavelengths of light are reflected to give those distinct colors. And because it only reflects light and does not produce its own light, that reduces its energy consumption by 90%. So only 10% of the energy that's used in a normal LCD screen is used in one of these structural display systems. The next innovation, the third, will be innovation derived from the kingfisher bird and bullet trains. So Japanese bullet trains have been known to compress air whenever they're going through tunnels. And because of that, there's a loud sonic boom at the end of the tunnel, which can be quite debilitating and scary for not just people, but also organisms. And in addition, the train is slowed down by the compressed air in front of it. So to help solve this problem, there was an engineer on the team who happened to be an avid bird watcher. So having seen that kingfisher birds have long, narrow beaks that they use to dive into water without splashing, he wanted if he could use that particular innovation from that bird and apply it to the train. And in doing so, the water is flowed around the beak and does not push the water itself. So there's no compression or very little compression. It just flows over the beak instead. And in doing that and applying that particular innovation from the kingfisher, bullet trains were redesigned to make a long, narrow nose for the train. And that reduced the noise, so there was no loud sonic boom afterwards. And it also decreased air resistance by 30%. So in reducing air resistance, that saves the train energy. So it doesn't use as much energy to get through. So it saves some money and saves some energy as well too. The next one, which is one of my favorites, is going to be termites and architecture. So Mick Pierce is an architect in Zimbabwe that has constructed a particular building that had to meet the requirements of a hot climate on a small budget. So the innovation that Mr. Pierce used was termite mounds found in Zimbabwe. So he used the different structures of termite mounds to help work with and create a building that was more efficient at cooling in that hot climate. So termite mounds are these very large structures found in African grasslands. So this is one, there's another here, and another here. They can reach 6 meters tall, which is about 3 times the height of an average person, more than 3 times the height of an average person. And they are made from soil, bark, and termite saliva. They can be firmer than concrete, and they are great at keeping temperatures pretty stable. So they don't get too hot or too cold. They keep it as is most of the time. So cool air at and below the ground is drawn in within these structures. So warm air rises and cool air sinks because of density. So the cool air will always be closer to the ground than warm air. So these blue arrows indicating warm air are pulled into the mound, and then throughout the day, as the air warms, the warm air rises and then is released from the termite mounds because there are these holes at the top that allow that air to escape. So as this air is released, this warm air is released, it creates suction, which then pulls in more air from the bottom and pulls in even more cool air. So things are kept cool for even longer because of this particular mechanism. And in addition, wind that pulls the warm air at the top would be pulling it more quickly and pulling it more forcefully, and that would speed up the cooling effect of the cool air coming in at the bottom of the termite mound. So this provides continuous cooling. It happens during the day as well as throughout the night, and it is monitored by the termites themselves. So throughout the day, the termites will go around and find out where it needs to be plugged up or where it needs to be opened up to allow for better ventilation. So it's a really interesting system that they have uncovered throughout the many, many years of evolution. So Mr. Pierce designed the East Gate Center in Harare, Zimbabwe to mimic just that. So it's made from concrete and brick, which absorbs a lot of heat without changing temperature. The building also has small windows and ledges to help to release some of that heat during the day and increase heat loss at night. So like the termite mounds, Eastgate has chimneys at the top, and these chimneys are for releasing any warm air, any hot air. So cool air enters from the bottom of the building at night, and sometimes they're aided by fans, but sometimes it is also just done passively. And in the day, when that cool air is warmed up, in each room, the warm air is channeled into a particular ventilation system. And then all of that warm air together is ventilated all the way to the top of the building and then released overall. And then that release will again pull in more air. So the more warm air that is lost, the more cool air that's going to be pulled in from the bottom. And that keeps the building at a good 24 degrees Celsius, even when even when outside temperatures reach up to 38 degrees Celsius, which is quite impressive. So this structure, this mechanism also reduces energy consumption by 35% and reduces energy consumption due to ventilation by 90%. It also reduces rent, so they don't have to pay as much for ventilation, so they don't have to pay as much rent. So everyone wins in a structure like this. So you get to save money, keep things cool, and also get to release some hot air during the day. So the last innovation will be coming from sharks. So last innovation will be coming from sharks. So sharks, everyone knows sharks, awesome creatures. Sharks have these scales called placoid scales or tooth-like scales, which are also called dermal denticles. Denticles because they're kind of tooth-like. And this is just one of the scales found here. You can see that on the scale, there are these small ridges, and these ridges are called riblets. In swimming, the different riblets of the scales allow the shark to swim through water more efficiently, reducing drag by 8 to 10% when compared to a smooth surface. So you'd think that a rugged surface would be a little bit more problematic when it comes to swimming, but a structure like this allows sharks to swim more efficiently so they can swim faster through water. In studying that, sharks have been the inspiration for Speedo's fast swim swimsuit. It improves swimming efficiency of the person wearing it, and it is made from a different material but the same structure. So this is the swimsuit itself here, and you can see that these are the different scales that would make up this particular suit that have that same riblet design that allow the shark to swim quickly, that can also allow the swimmer wearing the suit to swim more quickly and more efficiently through water. So this sharklet design has also been used in Airbus planes, on the wing tips of certain planes, to reduce drag during flights. And again, in reducing drag, there's a reduction in fuel costs, which then ends up saving more money and actually saving more gas or more fuel in general. One of the other benefits that have been derived from studying sharks and the same riblet design has been anti-fouling. So this is the propeller of a boat, and it's covered by different organisms. So this is a barnacle, and in between it, there are mats of algae and bacteria. And that is what biofouling is. So organisms growing on physical surfaces, that is considered biofouling if they cause problems, particularly for the structure they're growing on. So all these barnacles and algae growing on the boat, they will help cause wear and tear over time, but will also increase drag on the particular propeller, making it have to work harder and have to use more gas, which will cost more money. So everything is just hampered by biofouling in these conditions. But researchers have also used the riblet design to prevent biofouling of algae as well as bacteria. In different projects, they've reduced bacterial attachment by 90%. So of the amount of bacteria that was available to attach or able to attach, 90% of them could not attach to a structure that was covered in the shark riblet design. And overcoming the gaps in the riblets is too expensive for these particular organisms. So the different ridges that you do see, here, they prevent the different bacteria and algae from attaching, and that is too expensive for them to keep attaching here and then here and then here to form a stable mat. So they cannot attach, so they either die or get washed off overall. And this has been used in not just marine environments for the boats and ships, for example, but also in medical environments for the use of catheters, which is one place you do not want bacteria to be adhering, which is inside the body. So all these different innovations have increased efficiency, they have created new products and reduced costs throughout the human society overall. But they all stemmed from scientific observation. There was someone watching to find out why that happened, someone trying to figure out how that worked. So there had to be some curiosity within the particular researchers or even general people. And then there had to be some testing. So in being curious about why the plant burrs stick to a particular person, someone had to take up those plant burrs and look under the microscope to find out exactly how that worked. And then from that, they were able to design a structure that was similar to the plant burrs and add that into our daily lives. So we can see that from these innovations, greater investment in science is needed to lead more innovations that increase the quality of life for everyone. So no matter who you are or what you are doing, what your interests are, you as a regular person, as long as you're curious and observing your environment and willing to delve a little more deeply into different topics, you can also be one of the future innovators of our world. There are so many organisms on the planet that are interesting, that have so many fascinating ways, so many puzzling ways that we don't fully understand, but in studying them, we can and find different applications for making them improve our quality of life, not just for ourselves, but also for them. If there's a particular structure that can be more efficiently cooling our buildings so we can have more plants on them, then that would be an incredibly beneficial and less costly situation for overall societies. I would like to thank you so much for listening to the presentation. If you have any questions, any at all, please feel free to ask. Love answering questions and I love stimulating that curiosity. So if you do have any questions, please go ahead and I'll be happy to answer them.
So good morning, everyone. My name is Christina Arison, and I am the Senior Technology Officer at the NCST. Now, we want to thank Mr. Campbell for that presentation where he shared with us 5 examples of how nature, how our natural environment has been used for innovation. So questions, you may go ahead and type your questions in the chat, and I will just read some of the comments I see coming in. So the first comment is from Issa Bentoncourt, and I believe it was when you were talking about the butterflies, and her comment was so cool. All right, next from Oriane Ennis, and this was when we were speaking about the kingfisher bird, and his comment is that that bird has a wicked mohawk.
Yes, it does.
I agree. And then as it relates to the termite mound, Oriane Ennis, he also said, firmer than concrete and temperature is stable. Maybe I need termites to build me a house. All right, so Mr. Campbell, as we are on this point, so as it relates to the termite mound, this is something that can be used in residential buildings?
Yes, it is. So termite mounds, the structure of these termite mounds can be used in residential buildings, but the effect wouldn't be as great as it would be in a multi-story building. So you'd have in a regular home, you'd have the warm air rising to the surface to the top. And I'm not sure if you've tested this before, but if you're cooking and your room is closed or your house is closed, and you like stick your hand up in the air, you can actually feel that layer of warm air. So that effect would still be present in residential homes. So we would still, if your house had a chimney, we would be able to release some of that warm air at the top and then pull in more cool air from the bottom. So yes, it would still happen, residential homes, just to a lesser degree.
Okay, thank you. And other comments from Rochelle? Great presentation, Mr. Campbell. Thank you.
Thank you.
From Chevane, excellent presentation, Mr. Campbell. From Orion Ennis, he said, oh yeah, I experienced that the other day when I was painting the ceiling, right? So I guess it's the example you just shared.
Yes, yes.
So any other questions, you may go ahead and type it in the chat.
I see a question from Mr. Ennis regarding, are there any examples of biomimicry with octopuses? So yes, there are. Octopuses are incredible creatures. They are very ingenious. So they can mimic their different colors. They can change their colors at will using different cells in their bodies called chromatophores. And they can also vary the texture of their surfaces. So there are researchers that are looking at studying those particular chromatophores so they can find out and mimic how exactly octopuses do that and find out how to apply it to different surfaces. So you could have a smooth surface that on will or on command can change into a rugged surface depending on the environment. And it can be used in several applications, not just art or not just textured surfaces, but also in search and rescue events. So if they can change their form depending on what type of environment they're in, what type of environment they're going in, they can be better able and better suited to go through different challenges like a collapsed building or a fallen roof. So, thank you. That'd be dope to apply to here. Yes, yes, it would. All right, so if there are no more questions, I'd like to drop a question for you. So there is a survey link that has just been posted to the group. I want you, all the attendees, to participate. Just answer 6 very short and simple questions to let me know how the presentation was and if you'd be interested in finding out about more. Yeah. Right. So if there are any more presentations, questions that anyone would like to ask, feel free to do so. I'm giving about a 10-minute time for these forms to be completed, but if you have any questions throughout that time, please go ahead. I'll be here. Just let me know. I'm eager to send that. Oh, sorry about that. Yes. Oh, awesome. Yeah, so I had sent it to the host and panelists, not everyone in the group, so apologies for that. Also, there are several innovations that have been derived from other organisms as well. So if you want to know more about that, then please let me know. Do you think that biomimicry can be used to help with how we approach climate change? Yet that is absolutely. So there are different structures within organisms that allow them to come to cope with the changes of temperature and also different environmental factors that can be used in not just for organisms, but also other physical systems. One thing that comes to mind first is heat shock proteins, which are proteins that organisms provide or produce whenever they're exposed to extreme heat. So they have these particular heat shock proteins that prevent the denaturation of their enzymes when it comes to higher temperatures. So they would pump out more and produce different kinds. And that's something that can be used in genetic engineering for plants. So if they are more exposed to hot temperatures, hot climates, they can be reduced, their productivity can be reduced. But if they have more heat shock proteins within their structures, they can resist whatever changes in temperature do occur and can also be used to help mitigate some of the changes that we are seeing from certain emissions of organisms, as well as organisms re cattle, for example, and organisms re plants. But there are also several other possibilities. There could be so many different ways that biomimicry inspires changes in climate and also or changes in climate response. So we just need to get out there and do more research on these organisms to find out exactly how. And it could be even a mixture of several. So we could be working with different innovations from 3 different organisms and put them together into one particular thing. But one thing that I would like to note, yes, you're welcome. One thing I'd like to note is that in pretty much all of these, they reduce the cost of certain things so that they can use more money for other resources and also reduce how much emission gets pumped into the environment. So with biofouling, for example, if there is a lot of material that's on the propeller that's making it move more slowly, then more gas would be needed in order to get that propeller moving at the same speed or over the same distance. But if it's moving more efficiently and more quickly, then it would not need as much gas to get going. And as a result, there will be less, if there will be fewer emissions overall from that boat moving the same distance. So that's one of the ways, one of the indirect ways that biomimicry can help to reduce the effects of climate change overall.
All right, there's a question from Orid Edis, Mr. Campbell, and the question is, what would you say is the most interesting example of biomimicry?
The one that I mentioned was the one with the termites, because it just seems so simple. There is no added anything, there is no mechanical anything to add to it. It's just let there be holes in the top of the house and we are cooler. It just seemed so simple and so ingenious as well too, because there is no added anything to it. It's just plug holes in the building, in the top of the building, allow warm air to escape, and then that allowing it to escape pulls in more cool air from the bottom. That one was really inspiring to me because I love simplicity when it comes to being straightforward. That's always the way to go. And it's something that can be used in pretty much any building, and especially in the Caribbean here. If all of our buildings had holes at the top, then we could easily remove and release that heat that we do produce, or the heat that becomes trapped throughout the day. That'd be a great innovation for our future architects in Jamaica, as well as other hot climates. Yeah, Portmore homes do need holes in them. Agree.
Okay, and Mr. Campbell, there's also a follow-up from Mr. Orin Ennis, and it says, if you could adopt any biomechanism for yourself, what would it be?
I think I choose the shark design, like the shark riblets. Like if I could move through air, like I could walk more quickly, I could get to places more quickly, could save more energy when walking to places. So that would be cool. I could fly right easily through water, or swim easily through water and just walk more quickly. So I think that's the one I would apply. But there are so many others that could be out there that would be even cool. Like if I could get grasshopper legs, I would do that too because I could jump from home to work in like 3 steps. That would be awesome. Could become a shapeshifter. That would be great.
All right, so we have another question from Rochelle Daly. And the question is, this is a great example of why research is important. How do you think we could get the government to fund more research or to value research more?
So the first thing that, addressing this question, the first thing that needs to be done is to be showing the value of research. So a lot of the times people might think, people who are not in the scientific field might think that sure, science is beneficial or research is beneficial, but they don't exactly see how it benefits them or how the different innovations that they have within their lives have been derived from science overall. So the more we can get science out there, the more public we can have science shown, the better it is for everyone because these innovations have, as you've seen, have been shown to reduce costs across the world and create new products that we never even thought of. So getting advocacy out there, letting people know what science is, what it's for, who science are, how important it is one of the first steps in getting out there. And I think the second step would be attracting some funding, but that would be in relation to getting awareness of it. So the more aware people are of science, the more popular we can make science overall, the better we can get those resources to help fund science in the future. So whatever, if you're a researcher, whatever you're working on, publish it, yes, officially, but also engage people in it. Show them how cool your flies are, or show them how interesting different organisms are in your backyard. So get the publicity out there, let them know that science is not just an abstract thing. It's out here, it's active, and it improves lives. Here are also some references from the PowerPoint if you'd like to look through. And if you'd like, I can also send these to you so you can read more in detail on exactly what they are and how they work. Awesome. Is there anything anyone would like to say before we do close off? Hopefully you are finished with completing those survey questions. If anyone would like to say anything, just raise your hand and I can unmute you. The raise hand feature is right here. Okay, awesome.
Hello?
Awesome. Thank you so much for completing the survey. That helps us know exactly what's interesting to you and what needs to be out there more. So Ms. Morrison, you can go ahead.
Hi, Gavin. Very interesting presentation.
Thank
I
you.
was really taken with the morpho butterfly, and I'm wondering if that's the technology that I see them using to make the coverings of those cars that seem to shift right through the rainbow colors. I don't know if you know what I'm talking about, these sports cars that are out there, very high end. I'm
I'm not,
wondering if that's the structural color that they're using.
I'm not familiar with those particular cars, but I wouldn't be surprised if they're using structural color for that because it does have applications in not just paint, but like the cars as well too. They can be used for that. So there wouldn't be a need to get a paint job every week. You just have, as long as the structural color of the paint or the non-pigmented paint within the car is maintained, then you have that bright blue or bright red or bright green for however long you need. So it could be possible, yes.
When you think about the amount of plants and animals that have been, lost their lives to provide pigment for, it's really, really, really interesting that you can move forward at least and get a new sort of technology that would save some nature. Anyway,
Really good point as well.
thanks. I'm very interested in those papers. I'm wondering if you could forward some copies to them. I'll put my email in the chat so we could have them for the science library at the museum.
That's awesome. That's excellent. It's great to hear that the National Museum is interested and is willing to share this information. So we're happy to facilitate that. Thank you so much.
All right, thanks.
Does anyone else need to? Yes, the survey has been dropped in the chat. So if anyone would like to complete, just gonna drop it again. You can go ahead and let us know. Does anyone else want to say anything? Questions always welcome, comments always welcome. All right. Is there anyone who has not completed the survey as yet? I'm taking. Okay. Array is finished. I remember Rochelle said she had been finished. Awesome. Just going to copy this. All right, I want to thank everyone for attending. Thank you for participating. Thank you for your questions, for all the comments as well. It has been a great presentation. I hope that it was for you as well. And keep an eye out on our website, as well as our website is ncst.gov.jm. And you can keep an eye out on our Twitter account for any information that's coming up in the future. So our Twitter account is NCST Jamaica, and that's it. And from there, you can reach out, you can ever ask, can always ask questions, and we'll be happy to facilitate. Okay, that is everything. No more questions, no more comments. Oh, see a Q&A. Oh, thanks so much for the presentation. You're very welcome, Isa. And thank you so much for participating and showing up. It really is appreciated. Thank you. And thank you to everyone who showed up and participated. Thank you. It's awesome. Well, I hope you all have a great day. Hope you can take some time to stop and look at something small and be puzzled by it, so much so that you get driven to research to find out how it works. Hope you have a great day. Bye, everyone.